Hey guys, welcome back to Learn NWSE. So today we are going to solve LeetCode 3443. It's a very interesting problem. It's maximum Manhattan distance after k changes. So what is given in the problem? Let's look into that. So you are given a string S consisting of the characters N, S, E and W, where Si indicates movement in an infinite grid. So basically it is a 2D grid. Okay, 2D infinite grid, where N move north by 1 unit, S move south by 1 unit, E move east by 1 unit and W move west by 1 unit. Okay, so initially you are at origin 0 0. You can change at most k characters to any of the 4 directions. Find the maximum Manhattan distance from the origin. Note that from the origin. That can be achieved at any time while performing the movements in order. The Manhattan distance formula is if the coordinates are xi comma yi and xj comma yj, then it will be xi minus xj mod plus yi minus yj mod. Okay, so let's break this down first. Let's write in it note. So basically what n mean? N mean move north by 1 unit. So we consider north has plus 1 in y coordinate. Okay, move up basically. So S, what S will mean? It will be, S will be move south by 1 unit. So it is move down in y direction. So it will be minus 1 I. E means move east by 1 unit. Okay, so it will be plus 1 in x axis, plus 1 x, and W mean minus 1 in x axis. Okay, in this direction. So initially you are at origin 0 0. We have to take initial always at origin. Okay, so what is the formula of the Manhattan distance is this. This is the formula of the Manhattan distance. Okay, so let's look into one of the examples. So basically in this first example we are provided NWSE. Okay, so example NWSE is our string and here k is provided as 1. I will explain you what k is later on after explaining this example. So if we move from 0 to like in the n direction, then what will it will be plus 1 in the y coordinate. So it will be n will be 0 comma 1 in y direction. W will be minus 1 in x direction. Okay, so it will be minus 1 comma 1. Okay, and E will be n again, n will be again plus 1 in y direction, so it will be minus 1 comma 2. Okay, and then E is present. Okay, so okay here we missed that NWSE is there. So basically in the question it was S, but here we are also provided a k is equals 1. So what does k mean? Let's look into this. So k is something at, it's a position at which we can change at most k characters. At any location we can change at most k characters to any of the 4 directions. So if we change this S to N, okay, so we are changing this S to N to by using this k. So k is 1, so we can only change one element to any other direction. So we are changing this S to N. Why? Because this S is again making our this thing, like if it were S, then it would have made this thing like this, like after 1 comma 1 minus 1 comma 1 it will be minus 1, and if it was ns, so s will be minus 1 in the y direction, so it would be 0. Okay, so to maximize the Manhattan distance, what we are doing, we are changing this s to n. Okay, so again in this E, So what does E mean? Plus 1 in x direction. Okay, so it will be minus 1 plus 1, so 0 comma 2 according to this n by taking this k equals 1. Okay, let's delete this because we are not considering this. So if we try to calculate the Manhattan distance according to this formula, where xj comma yj is always 0 comma 0 and xi comma yi is the current coordinate. Okay, so it will be simply 0 plus 1, that is 1. Okay, and this will be simply mod of minus 1 plus mod of 1, so it will be 2. Okay, this will be simply mod of 1 plus mod of 2, so it will be 3. It will be mod of 0 plus mod of 2, so it will be 2. So what is the maximum Manhattan distance we can get here is this 3. So our output will be 3. Okay, understood this? So move on to the next example. So it is NSWWEW, k is 3. So here we can change at most 3 characters, like this part changing from n to s, and similarly we will be getting an output of 6 here. So what are the constants here? The string length is less than equals to 10 to the power 5, so basically the changes in directions is less than equals to 10 to the power 5, and k, that is the number of such kind of changes which we can make, is less than equals to the string length, and s consists of only 4 characters, that is NSEW, north, south, east and west. Okay, so if we try to solve this problem in a clever way, so what can be the formula? So if we try to calculate the Manhattan distance, then what distance can be? Distance can be mod of n minus s, north minus south, okay, plus east minus west. This is the normal formula, right? What change we are provided from the normal formula, like what kind of deviation is there, we are also provided a k. So what can we say here, that if we are going in the normal way, then it is normally this formula, but if the k is provided, if the k is already provided, so it will be a little bit of change. Like if in this case we can see the k was not provided, then it would be s, okay, and it would be 0 comma 2, so the output would have been 2 instead of 3. Okay, so what we can see here, if we change any direction using this k, so each change can help you move up to 2 extra units from the origin. Like if the change was going to happen in the plus y direction and we change it in minus y, then it is going to give us 2 extra units, like the plus y part and the minus y part. So it will be like plus y minus of minus y, so it will be 2y plus 2y. So the difference, that twice of difference. So we get 2 extra units for each such kind of change made by k. So what we can state that as, it is going to be 2 into k according to the logic. Okay, so by this twist of k, we are getting the Manhattan distance formula as this. So we can also look into another part, like if we are at step 0 and we are moving to some step like n, s, e or w, so whatever be the number of step, it will be the number of index plus 1 only. So the output will be the minimum of this distance and the I plus 1, like the index plus 1. Okay, so at whatever index we are currently, we will be getting plus 1 at the output extra only, right? Like if we are at the index 0, if at index 0 n is there, so what does n mean? Plus 1 in the y direction. Okay, so if we can say that at index 0 we are getting plus 1, so at index 1 similarly we will be getting plus 2 if we again put n, and then in index 2 we will be getting plus 3 if we again put n, and so on. So I plus 1 will be there, and we can also say here that this output is like this, and in each case we will be taking the output should be the maximum, right? So what it will be, output will be something like max of output comma minimum distance comma I plus 1. It will be like this. This is only for your explanation, and the final one will be like this, like we need to calculate the maximum Manhattan distance, so it will be output comma whatever minimum we are getting among these. Okay, so let's move into the coding part of this problem. Let's try to code this up. So we are provided a string s and an int k. So first we need to calculate the size of the string s dot length, okay, and we need to initiate all those four, n equals 0, s equals 0, e equals 0, and w equals 0 as an integer. Okay, so it will be like n equals 0, s equals 0, w equals 0, and e equals 0. Okay, now we need to make an output, initiate the output as 0, and then we will be calculating this further. Okay, so it will be like we need to run a loop from the index 0 till the index like n minus 1. So it will be for int I equals 0, I is less than n, I plus plus. Okay, and we need to start, like we need to iterate each character of the string. So we will be making a char c, which will be initially which will be pointing to the ith index. Okay, so it will be like s I. Okay, and what we use to like change between this n, s, e, w, whatever string is provided. So here we can use a switch case statement. So it will be like switch whatever the char is according to the char, and it will be like case, if the case is n, if the char is n, c is n, this c is pointing to the n, this first one, then what we'll be doing, we'll be incrementing the n by 1 and then breaking the statement. Okay, similar goes for the s, e, and w. So we can copy this. Okay, so just change this s, this is a capital S, right? Similar goes to E as well, and similar goes to the W as well, right? Okay, so how we were going to calculate this distance? Let's see. We have created this formula, the Manhattan distance formula, to calculate the distance. So it will be similarly like in dist. Let's copy that only. So it will be the calculation of the Manhattan distance, this absolute value, because we are taking the mod. So to calculate the mod, we will be taking this thing, and absolute value of n minus s and plus the absolute value of e minus w. Okay, plus 2 into k is the extra calculation which we are provided, this k1, like this changing from any one direction to any other direction. These k number of changes are only allowed in this question. And the other thing to calculate the output will be this other one formula, right? So we will be simply copying this and take. Okay, so it will be similarly this one, output equals max of output comma minimum of distance comma I plus 1, because at each ith index, like the maximum output which can be is I plus 1. If 2 into k, providing very high values compared to what we should get in actual. So basically this output is calculating this our output by taking the minimum of this distance and the I plus 1 index, because what maximum can the output be is I plus 1. So whatever is smaller, the distance or the I plus 1, the index plus 1, that will be coming to the output, and it will be comparing with the previous output, and whatever the maximum of those is, like whatever the maximum of those in each iteration, so we will be getting that as an output in this. So we'll be simply returning the output. So let's see if it works well or not. Let's run this. Yeah, so here we have simply missed this semicolon. Let's run this again. So let's submit this. So yeah, it is working fine. Hope you guys liked the video, and please do subscribe. Thank you for watching.